Okay, so 5.6 is graphing linear inequalities on a coordinate plane. All that we have done so far is graph inequalities on number lines. Like, for example, when we did this, when we had something like that. All you had to do was -3, -3, and then you did x is greater than 1. You went and found 1 on the number line, you did an open circle, and you went to the right. So that is an inequality, but now we have two variables. So when we have two variables, we have to do it on a coordinate plane. So for example, if we have y equals 2x minus 4, this would be an equation. The only thing that's going to change today is the sign right here. And it's going to change to greater than, less than, greater than or equal to. It could be any of those, just like we had when we solved them before. So you are going to graph these like normal. So like you're going to find the y-intercept, and you're going to find the slope, and we're going to use those to get some dots on here. So my y-intercept I can see is -4. So I'm going to go down 4 and put my dot. And then my slope I can see right here is 2, or 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Now, at this point, normally we would just draw our line and be good to go. But because it says greater than, this is where things are going to change. If you see a greater than or a less than, we are actually going to use a dashed line, because it doesn't have the equal to. So it means it could come up to that line, but it's not going to be equal to. So I'm going to go ahead and use the dashed line across here. I'm still going to put arrows on the ends to show that it does keep going on forever. And the last thing that we have to do is we have to shade appropriately. Because it says greater than, it means that the answer is not just where that line is. Instead, we call this like a boundary line, meaning like the solutions can come up to this point. So where we have to figure out is where to shade. Well, the easiest way to figure out where to shade is to test a point. Sorry about that. So again, we need to test a point. Well, you can test any point you want to. The easiest point to test is 0, 0. And just because 0 is very easy to put into the equation. The only time you can't test it is if the line is actually on 0, then you can test any other point you want to. So when you test a point, this is going to be your x and this is going to be your y. So I'm going to go back to my equation, or my inequality. Y is greater than 2x minus 4. I'm going to take the x out and put in a 0. So put in the 0 for x, and put in the 0 for y, because it says my x and y are 0 and 0. And now I just go ahead and solve. So it says, so it says 0 is greater than, 2 times 0 is 0, minus 4. So let's see if this is true or false. 0 is 0 greater than -4. Well, yes, 0 is greater than -4. Because this is a true statement, I'm going to shade where the point actually is. So see this big green dot right here? This is what I was testing, and I said yes. So if this dashed line is my boundary line, I have to shade everything on this side of my boundary line. So it means any point that falls on towards the, I guess you would say, left of the line, those are all going to be solutions. If it falls over here, it's not a solution because it's not in the shaded area. Okay, so in that last example, these were kind of the steps that we did. One, it was already in y equals mx plus b, so we didn't have to do much there, but you do want to make sure it's in that. Then we graph the line like normal, and then we check the inequality sign. So on that last example, it was greater than or less than. That was a dashed line. Well, if it's greater than or equal to, or less than or equal to, whoops, sorry about that, or less than or equal to, then that's just a solid line. So the only time you really have to check is make sure if it's one of these, then those have to be dashed. And then again, you test a point. You can test any point you want to. I usually use 0, 0, and then we just shade wherever it's true. So if we say true, we shade towards the point. If we say false, we shade away from the point. So let's do another example. Let's just say we have x is greater than or equal to, let's go 5. Well, first of all, this is just going to be a vertical line because I don't even see a y in there. So I'm going to go find where x is 5. 1, 2, 3, 4, 5. And then it's a vertical line. I'm going to check to see if it's dashed or solid. So looks like this is going to be a solid line. So I'm going to put a vertical line at 5. And again, that's your boundary line. I'm either going to shade over on this side or I'm going to shade over on this side, but you cannot shade on both. Okay, so again, I'm going to choose to test 0, 0. Well, my 0, 0 is right here. And I don't know, I like to make the dot so I know if I'm going to shade towards that dot or away from that dot. So for this one, you just need the x. Is 0 greater than or equal to 5? Well, no, 0 is not greater than or equal to 5. So because we said no, we're actually going to shade away from where 0, 0 is. So you're going to shade all the way up to the boundary line. So every solution on this side, or every dot on this side where the shaded is a yes. If you put a dot over here, that is not a solution because it's not in the shaded area. So for inequalities, you're checking the shaded area. And then one of the, actually I think it's the first thing you do, but last thing I'll show you is just how to test a solution. So in order to test a solution, you need a graph. Okay, so it might look something like this, and you literally, it's just a yes or no question. So 0, -1. If I go to 0, -1, 0, -1 is right here. Well, 0, -1 would be in the shaded area, and I know I didn't shade quite close enough, but anything all the way up to that border is a yes. So you just write yes. 0, 0. Now, this one's a little bit tricky. It looks like 0, 0 would be a yes because you can see a big dot over top of 0, 0, but you have to check the dashed line. Because it's dashed, this is a no. If this was a solid line, it would be a yes. But because it's dashed, it's only up to that line. It doesn't include the actual line. Okay, and then -2, 1. -2, 1. You can see that the -2, 1 is not at all in the shaded area, so that would be a no.